Okay.
So, um, I guess we can start a presentation, or is there still somebody in the Google meeting?
No, you can start.
Okay,
Oh, you heard me now.
good. Yeah, yeah, I heard you.
Ah, okay.
So here you can speak again
That's
now too.
so annoying.
Yeah, yeah, there were probably a bit too much restrictive permissions in the stage event channel.
That's so annoying. Okay.
Yeah, so yeah, I think most people are here now, and we can start the recording and the presentation now.
Yes.
So, yeah.
Thank you.
Then I welcome you to the presentation of SkyCAM6. Um, if you have been to Estal, maybe you know this friendly animal here. Yeah, and yeah, about myself. Yeah, just yeah. So I hope you can all see the presentation. It's a bit it's not linear. It's a bit yeah, different. So what I'm going to talk about today is first myself, then about the SkyCAM system, how the architecture works, what the software does, and our goals we have with this project, which Hakan has with this project and other projects. And yeah, let's get started. Hello together, my name is Marvin Baral. I study aerospace computer science at the University of Würzburg in Germany. I'm currently at the end of my master program, and yeah, I have been here in Würzburg for quite some time. And in these years, I started another project with some students alongside my studies called T-Rex Tracking Rocket Experiments, and there we built and programmed an optical tracker to follow rocket launches, so to detect a launching rocket, its position, and follow it. And yeah, that's something that probably is also interesting for UAPs. And yeah, but I had to yeah, let that project freeze and do some other stuff. And now I'm an assistant for Professor Hakan Kayal, and I'm yeah maintaining the SkyCAM6. I brought the SkyCAM6 system to Norway and installed it together with Magnus help. And yeah, I'm currently maintaining it remotely, and I will also be in Trondheim next semester. I have a semester abroad at the NTNU, so I will be very close to the Blue Blocks. So if there's any maintenance or any event going on, like the field trip weekend, I will be there too. Yeah. So, we are here for the SkyCam system. About the SkyCam system, you first have to know that there's for quite some years now the SkyCam 5 at the University of Würzburg. It's on a university building. It's an all sky camera that looks up in the sky, and yeah, it detects moving objects and classifies them and stores them in an event database. And this is the camera that is on the roof. And no, no, that's not what I wanted. Ah, that's what I wanted. Okay. Uh, don't click. Um, you saw on the top of the roof we have the all sky camera, and below the roof we have our camera server, which does the processing load. Um, and the same is true for the new SkyCAM6, which I brought here to Hestal. And these are two cameras. More specifically, we have here two cameras from the manufacturer IDS with 2000 by 2000 resolution. You can see the more details there. Running at 85 frames per second. And the idea why we have two exactly the same cameras is maybe also redundancy, but the main thing is that when we have an event, when we have recorded some unusual phenomena, that we want that recording to be credible. And in order to be credible, to exclude sensor artifacts, to yeah, exclude certain errors, we, it's just very advantageous to have two camera system both independently recording the same event, and then you have a more credible outcome. So yeah, you can see they are both mounted on the wooden roof with some enhancements to keep them sturdy. And yeah, then we also have a camera system inside the blue box. You can see we have here the working monitor shows the image of the two cameras, and maybe you can see in the down the big black box, this is our powerful server which does all the processing load. So this architecture is for both SkyCams. We have the cameras which are connected to the camera servers with a very high data rate. So for SkyCam5, we had a camera which used PCIe over fiber optics. And now here in Hesdalen at the SkyCam6, we have 10 gigabit Ethernet connections. They aren't used completely, but 1 gigabit wouldn't be enough. So we have these cameras with the camera servers, and they are out in the open internet, and they do the heavy processing, the detection, and the analysis. And after they have done that, they send the processed event, which consists of a thumbnail, some database entries, and the video. They send this to the UCP server in Würzburg. UCP stands for Unknown Celestial Phenomena. And from this server, our every device that runs our clients can connect to the server. But they have to be in the local network of the University of Würzburg. That is also the problem why we can't easily give others access to our database, because our main server is located in the university network, and you need to be a member of the university to access it. Yeah, so here you can see our complete client server architecture. And yeah, are there any questions up to now for the architecture? And can you hear me well? Is the audio okay?
I can hear you well. Yeah. thumbs up.
Okay, very well.
That's
Nice.
nice.
Okay. So now you know the general network architecture. Now let's focus on what is actually running on these camera servers, these very high processing load camera servers. No, yeah, you can see our clients can install the clients on your laptop. It would look something like this. And we also have in our mission control room in Würzburg for our satellite, we have one separate station which is dedicated to the SkyCAM systems on the right. Yeah. But now let's come to the camera server. The server that is located in Hessdalen has a very powerful GPU, NVIDIA RTX 4090, Intel CPU with 24 virtual threads and 64 gigabytes of RAM. So it's definitely a lot of computing power, and you also need this because you have two cameras running at 85 FPS with like 5 megapixels. There's just a lot of data coming in that needs to be evaluated. And we designed our software using C++ for computing efficiency. Qt Creator, the standard C++ environment, and we support the CUDA acceleration in order to use this big GPU, and yeah, we use OpenCV for classical computer vision and TensorFlow for the AI component, which I will come to later. So the first steps that our software does are actually relatively simple. We just permanently try to detect movement with background subtraction. So we first save a still camera image and then calculate differences to this camera image. And a fast moving object is then a very obvious difference. And this will then be detected. And then if there are multiple detections, an event will be recorded. But first, we have a filter which masks out certain areas of the image which are known to produce a lot of false positives. So you can see here that the picture on the left is from the camera in Hessdalen. It's not the best lighted one, but you can see two power lines running on the right of the image through it. These are jiggling around a lot in the wind, and also some trees on the left that are above the horizon, they also move. So they would generate a lot of events which we do not want, and that's why we have an mask to mask them out, to ignore these movements. Another thing which you don't really see here is there's a road which is directly oriented towards the camera. So there are some headlights shining directly into the camera. This is also masked out. Yeah, and after the movement has passed through the mask, if it is not one of the masked out objects, there are still multiple criteria before our software decides to actually record the event. We have to detect the movement in multiple frames. It has to have a certain level of sharpness, and the complete event needs to be below a certain threshold. So if we have an event that takes place over like 10 minutes, we will discard the event as, yeah, we think it might be clouds or something like that. Yeah, and if all these filters are passed and all criteria match, then an event is generated in the database and the video is saved. And then our AI steps in. Our AI classifies the recorded videos into certain categories. And we do that in the following way. We have multiple neural networks, which each only are trained on one class. So we have one network that is trained on birds, we have one network that is trained on insects. And all of these networks analyze the video and decide if their class matches this video or doesn't match this video. And the design goal which we want to reach with our AI is to filter our known objects so that only the unknown objects remain, and ideally the unknown objects remaining would only be the real unknown phenomena, the phenomena that can't be explained with usual means, that are the ones we are interested in. So to clarify that, we are not searching for an anomaly. We are filtering everything out except the anomaly, so that the anomaly remains, hopefully. So it is very important that when anomaly actually occurs, it is not classified as a known object, and that was taken into account into the training to make very sure that it is only classified in a known object if the AI is really sure. Yeah, and another way to make sure of that is that we look how many networks match, and only if a single network determines, yes, this event belongs to my class, only then is it classified as this class. If there are multiple networks claiming this video to be in their class, the event is left as unknown, and if there are none, it's obviously also left as unknown. Yeah. So that is the AI part behind all of that. And so in the end, in the client, you get a list of all the events, and you can just filter for events with the class of unknown and look through these events and hopefully find something interesting. So I shouldn't click only buts. Yeah, that's how the software works. And we, of course, have some plans for the future. We know that a lot of you guys want to help us with classification or look at the data, but up to now we haven't been able to give you any access to give you access to our client. That was because of the aforementioned problem with the university network, that you have to go into the university network to connect to our server. We will try to change that in the future to bring our server in the open internet, where it is less protected and more accessible. But that needs some time, and yeah, we don't have a lot of manpower assigned to the project. It's not funded by third parties. It's yeah, yeah, very limited manpower, very limited budget. And in the far future, we don't put a date on it yet. We also want to go open source to share our code and to develop it further together, maybe even together with some of you guys. But we first need somebody at our university who can dedicate some time to maintaining the repositories, to reviewing pull requests, to yeah, generally keeping stuff in order. And we don't have that kind of manpower yet in this project. Yeah, but where we have a lot of manpower in the other projects, they might also interest you. They go slightly in a similar direction. We have a satellite in orbit. It launched just this year in March, also in the same month as the SkyCAM6 went up to Norway. And this one also does AI on orbit, and it demonstrates on orbit training, and it's also looking for anomalies. So yeah, there might also be some interesting things showing up, but up to now, yeah, we just see nice images of the Earth. And we have KI-Sense. This is divided into multiple projects. Probably the most interesting here is Ground Sense, a telescope which has also newly been mounted on the University of Würzburg, and that is looking up in the sky and trying to track space debris. So it moves pretty fast for a telescope. That's why the dome opens up completely, but it wouldn't be fast enough to use together with a SkyCam for like tracking a bird or a plane flying by. And it also has a extremely low field of view. So it does some tracking, but it's difficult to if you would want to create that in the SkyCam. Yeah. These are there are also further projects done at our chair of Computer Science 8, but these are probably the closest one to the SkyCam project. And yeah, it was. I hope I could bring you a lot of information, and yeah, I've worked well together with Magnus to bring up the SkyCAM6, and I hope we can still yeah, work together further. We will meet each other at a field trip event and stuff like that. So yeah, thank you for listening to this presentation.
Thank you very much.
There will,
I guess you will take some
yeah,
questions. Yes,
yes, I will take some questions. Yeah.
I have some, but I guess maybe others too. Let me see. I muted one that was making some noise, but I'm gonna unmute in case there's some questions. Uh, the first question I'm expecting, I'm just gonna give it myself. Have you had any events?
Yeah. Um, there were some events which were interesting, but yeah, nothing certain. Um, Actually, we could still after the question around, we could maybe look at some recorded events. I could share them on the screen, and I have also a live demo prepared for you, so I can show you the live image from the cameras in Norway and a live view of our client, so we can look on events there
I would love that. I would
of
love
the
that.
detection.
If anybody else have questions, please unmute yourself.
Yeah, I have a question.
Yeah.
Question one is the trainings object. You mentioned helicopter, but I didn't see airplanes.
Yeah. These were just some examples. I can show you the client. Let's do the live demo of the client now. There you can see all of the classes. It's just or maybe let's just ask for further questions on the slides. Then I can finish the slides and open the client. But to answer your question, there are a lot of classes. I think like 10 or 15, and planes are definitely one of them.
Okay. My second question is when there is something interesting, how long time does it record, and how long time does it record?
It records the event for the time it detects movement. So it starts of course maybe a few frames earlier, but we have like short events, which is just like an insect or bird coming through. Then you have like 20 frames or something like that. But sometimes our system falsely detects clouds as objects, and then it can take very long, the whole recording. So as long as movement is detected, it records.
Does all these recordings, which are also false and not interesting, do you remove them from the database?
No, everything recorded we leave in the database. We need this for further training. Because we train for the known objects. It's we need these known objects. We need helicopters. We need birds. We need clouds to train our models. So they will all be saved, and there's the possibility to label them. So our client has the option to assign a human class by it, and then everything that has assigned a human class by it, as a class assigned by a human, this data can then be used for training the model again and improving it.
Thank you. Thank you.
Anybody else that wanted to have some questions? While somebody else will unmute themselves, I have a question about the cost. If you want to make another system like this, and then the computer and the cameras and the casing and all that, do you have a rough estimate in?
Probably a bit difficult for me because I didn't buy a lot of the components. But of course, at least 10,000
Yeah, yeah.
euros. That's most definitely. So the first number that comes into my head would be like 15,000 to build a similar system. But I'm also planning to make a documentation of the system in a form that it is also an instruction manual to possibly replicate that system. And yeah, I can add the costs in there too. So yeah, maybe you will get that in the future.
So the system does require that you have good power and also good internet.
Yeah, but you don't need a lot of internet. Of course, you need a stable connection to be able to communicate, but we have actually, let's look at it on the slides. As you see here, the main data transfer is between the camera and the camera server, so it's all local. It's these 3.5 gigabit per second. This is local inside the blue box, and from the blue box to Würzburg, it's just these single events with some database annotations and a video. So it isn't even the continuous traffic. It's just when an event is detected and analyzed, it is sent to Würzburg, and then it's just like a short video, and that doesn't require much bandwidth at all.
It would be nice to know if you have some numbers of how much is being transferred. The reason is if it would be possible to use some kind of 4G subscription to transfer, and then there's always like a limit to how much you can use during a month.
Yeah,
Yeah.
yeah,
So
yeah.
if you get that
So the
number,
total amount.
yeah,
Yeah, klar,
after
klar.
some experience, I
We,
guess so. Yeah.
yeah, yeah. I'll
Yeah.
think about that. Yeah. And you also mentioned power. The power consumption is surprisingly low for how beefy the computer looks. I mean, it probably looks like it consumes a kilowatt, but it actually is. I think it stays even below 300 watts, or it's around 300 watts. I have roughly in my head.
Mm. So with some big solar panels, it could be possible to put it somewhere. Beefy.
Yeah. But for that system, you would need a lot of solar
Well,
panels.
if you look at some Norwegian cabins, they have enough solar panel to do cooking and vacuum cleaning and everything.
Yeah,
Yeah.
yeah.
Okay.
But then you would have again more costs for the solar
That's
system
true.
and would probably be double the
Yeah.
costs.
Let me see. You were tempting us with to show something. Did you do you have you said you had some events that maybe you could run through and show? Is that possible? Yeah.
Yeah. If there are no further questions, I can close the
Oh, if
presentation
people have
actually.
questions, they have to
And
unmute and come forward and just interrupt. Please do.
Just a comment to you,
Yes.
Fred. I think your mobile station for this that we could put up in a mountain ridge, which of course something we want to do. But I think there are more lightweight systems that are more suitable for that, at least for a start, and cheaper for that matter. Because yeah, more lightweight and cheaper. That could still bring value.
yeah, if you would be planning to do some kind of mobile system, probably yeah, be more advantageous to use a embedded computer like the NVIDIA Jetsons. That is something we look a lot into. We have tried sometimes, but we haven't completed NVIDIA Jetson system yet.
And
But that's be also an
yeah.
interesting option.
If you can do multitasking, then I'm gonna ask you. The first phase is like you have a number of filters before you go to the AI. So this first
Yeah.
phase, would it be possible to send that over the internet so the AI could be processed somewhere else? Because you have events that you get after your filters, and then these events will then be going through all these models of the AI, and then it sounds to me there are like two phases. Could it be possible to send more data over the internet and say, okay, let the AI run somewhere else?
Yeah, I mean, that's probably the AI doesn't need to run live. It's just the classification. So yeah, true. You could change that.
Be more internet, but yeah,
Yeah,
okay.
yeah, yeah. It would probably be the same amount of internet. It would just be the assignment of the class happening later. But I'm not sure. But yeah, yeah. I'm not sure how much power the classification needs, but it's probably not a lot.
Okay.
Yeah, I'm
And
not
how
really
how
sure.
do you are you the one that is kind of setting up the models to train the AI? Like now you have it sounded like you had the number of models like 15, 10, 15. So it's this model, is it an airplane? Is it an insect? And so you get the yes, no on each of these. And I guess if all of them are no, then it's an event. But when you start a new training session, is it because you have been looking at the data, you've been looking at the video, and you think that this should be a bicycle or whatever? I don't know.
Well, I haven't done any training of the data yet. I'm just here for since roughly 1 year. Um, I've mostly worked on yeah, bringing the SkyCAM6 system together, completing it, and getting all the components working. But what I can tell you about the models, we don't have models for all of our classes. So yes, we have like 10, 15 classes, but we haven't trained all of them. What we have trained, for example, are birds and insects. Um, and we have, yeah, we have multiple models, but the really good working model is definitely the bird model. That one is pretty good in detecting birds. Yeah, some other models might need some improvements or might need to be trained for the first time.
This training,
Um,
does that mean that somebody has to look at the screen and see, this is an insect? Does somebody has to kind of go and say what classification is should go into it? Are you looking for people to assist on this, or would that be useful?
yes, yes,
Yeah.
exactly. Yeah, yes, most definitely. So for training, you need some ground truth, and yeah, well, the only way to obtain that is by humans classifying these things, so that you have the ground truth that you know this video is a bird, this video is a
Hmm.
cloud. In order to have that, a human needs to go through all these
Hmm.
videos. Uh, and we actually have a huge backlog of classifying these videos. We have a backlog reaching back to 2022.
Okay.
Yeah,
Okay.
a lot of events to be classified. And we would appreciate help of everybody who just wants to click through these events, like on a I don't know, like on an evening with a cup of coffee,
Yeah.
like sit yourself on a couch and click through a few events as long as you want. So we definitely want that to be possible and want you to be able to do that. But as I said, yeah, the server architecture is a bit problematic here because we have the server inside the university network, and yeah, you need special
Mhm.
access there.
This
So
this is just a technical problem in a way, and the moment that is solved, then we could get
yeah,
people to kind of go through them and help in that classification and training the models, right? That would be,
exactly, yes,
yeah.
you could download our client. It's yeah, it's mainly designed for Linux for
Hmm.
Ubuntu, and yeah, you can download that, and if you when the time comes that you get access to it, then you can use it to click yourself through the
Hmm.
database, and yeah, that's definitely something we
Yeah.
want.
I have a question.
Yeah.
Is this system also suitable for triangulation if we put up another camera further away, so it's possible to do some calculation of distance and triangulation? Will it be possible?
I mean, yes, it's in a manner of speaking, everything is possible, but it's not implemented yet. So you would need to implement it, and it's also a bit problematic that both cameras are running independent of each other. That's because of the design philosophy we had, that we want two independent measurements. We also have for each camera a completely own different process, so they are not interacting with each other in order to not influence each other and bias some results. But this has the disadvantage that information exchange between the two cameras is more difficult. What you could definitely always do is just take the two videos and do sort of some manual triangulation, maybe write some Python helper program. But yeah, it's it would be a very big feature to implement. It would take some manpower, and yeah, it would be a big step for us.
I have another question. Is the system, well, as it is now, you're analyzing cameras, videos, but
Yeah.
is it possible to take inputs from other signals? I'm thinking of a flight detecting system. We have a flight detecting which detect every plane which send out the signal. Could that information from this flight detection system go into the computer and in a way help decide if it's a plane or not?
Actually, yes, we had a bachelor thesis about this topic, which used an ADS-B recorder, exactly the same thing you were talking about, for receiving plane positions and reporting them to the camera system. I'm well, I'm not sure how close it is to actually being working. It's most definitely not integrated in SkyCAM6, but there was some work done on it, and probably if some more work is done into that, it could be integrated into the system. Yes.
Thank you.
Yeah.
I
So
can comment comment on a little, just my experience from running some cameras in Hästdalen for a year now is that birds are definitely, I would say, number one known that can be, captured as a false positive. So if you have a really good birded network, then that's good. Airplanes should be relatively easy to train because they move linear, they look the same. I mean, either if it's daylight, you have a character. If it's nighttime, they have the strobe light and navigation lights, which is should be pretty easy to recognize. So I think birds and insect time, those are the two big ones in Hästdalen. Practically, that's my experience.
Yeah, most definitely. If I look at the past recorded events, I also see a lot of birds and even more insects.
Yeah.
So then I think we we have switched from the presentation and are no more going into the direction of looking at the client and looking at events. So you can continue asking questions, but I will just now show the client instead of the presentation. So, screen. This is right. Yes. So here you can see the SkyCam client running. Do you see
Yes.
it?
Yeah.
Yes. Okay. So on the right side, we have some live telemetry from all three systems: SkyCAM5 in Würzburg and SkyCAM6 1 and 6.2 in Hästdalen. You can see here they are running. The time here is UTC. Yes, it's the same one as on my system. And yeah, they are running at around 80 FPS, both cameras. We actually had some issues with the second camera dropping down sometimes, but we recently did some cable changes with Fred and Rainer, and yeah, this worked well up to now. Yeah, so you have the telemetry. In Würzburg, we even have some humidity and external temperature sensors. But on every system, we have a camera temperature sensor. It's even it sometimes gets pretty hot inside the camera. Despite being in Norway, if there is bright sunlight shining on the camera, it can also go up to 50 degrees Celsius. Yeah, and yeah, the thing you probably are most interested about is here the event viewer. So every event that is recorded lands in our database and is shown here in the client. And you can scroll through them and see some thumbnails. Yeah, these ones are most definitely birds, and they are also correctly classified as bird. Here with class bird assigned. Oh. A lot of birds and insects.
So I thought I saw a fish in the sky.
A fish in the sky. Yeah, that's probably a bird with its wings retracted. I know what you mean. I also saw that. Yeah. in a lot sometimes it's oh here it's just a bird photographed at the moment that it has retracted its wings.
Look pretty. Are they zoomed in? Because they look kind of blurry as like a little blob.
Yeah. I can show you a video of them. Here we have a video button that opens the video, but sadly here, at least on my system, I have a small bug which doesn't show it directly, but I can show it you with a slight workaround. You still see that? Ah, no, I need to change the screen sharing for that. Share screen. I want to show the whole screen. This. Yeah. So, can you see the stream
Yeah.
again? Yeah. So here you see the video of the event that was recorded. I've opened it in Avidemux. That's my favorite external video player if you want to go through videos frame by frame. And you can see here, yeah, something like a bird or maybe a bat or maybe some insects flying through the image. And you can see the frames where it was detected by our motion detection. Then there was a red box painted around it, and the thumbnails are generated within this red box, so it's very zoomed in, these thumbnails. So it's probably maybe that picture here was the thumbnail and only the part with the red borders. Yeah. I have something interesting here. Yeah, I can show you a thunderstorm that recently happened here in Würzburg, where our Würzburger system detected a lot of them. Here's the GIF. Yeah. Hope you can see that. Yeah, you can see that. So that's this one was recorded by our camera in Würzburg, and you see you have a lot of actually a lot of frames for lightning. I mean, lightning is very fast. It's surprising to even have multiple frames, but you can see how the lightning develops and even some afterglow after the lightning.
These lightning researchers, they have 10,000 frames per second, or even over 100,000 frames per second.
So sorry, Magnus, I couldn't understand you completely. Can you say again?
Magnus, can you? I think he was asking about the frame rate.
Yeah, and in the SkyCAM5 is operating at a lower frame rate. It's no. It's around 40
Okay.
FPS. Let's look here. Yeah, here you can see 40 FPS. Don't be misguided by that 10,000 FPS. That's that is like the commanded frame rate, and this down below is the actual frame rate. Oh.
Oh, you are the one that have to go through these and see what you find.
Yeah, I mean, I go through these sometimes. Hakan also goes through these every day. It's it's part of his morning routine. The first thing he does when entering the office is he looks at all the
How
events.
many events do you have now every day? Is it like 10 or 100?
Yeah, it's a lot. You can see here that the client shows 500 events at maximum, and it ranges from the 8th of July, 19 o'clock, to the 8th of July, 6 o'clock. Yeah, so a whole day has 500
Okay.
events. Yeah, so that really is an amount that you can't we can't manage anymore. That yeah, that we need to find some better filters or a lot more
Yeah.
people to do that. And you can see here there's the event evaluation. That's the thing where you actually can do the classes. So you see here all the available classes from unknown insect, raindrop, snow. Yeah, there you have your plane, lightning, all kinds of stuff,
Hmm.
even some leaf. So when you want to classify an object, I mean, this here was just one that looked pretty much like a bird. If I look at it, the moment, um, 28644. No. Let's look what this actually was. Ah, I think it's a helicopter actually. Doesn't flap its wings. Yeah, it's actually a close one. I'm not 100% sure if that one is a bird or a helicopter.
I have a question.
Yeah.
The training object, which you mentioned there, are they trained by you only, or can they be trained on other camera system? Could you pick up some info for other training which has done this training, or does it need to be exactly the same camera as you have? So you have to train it yourself?
No, it's not restricted to the exact camera. I mean, we have two completely different camera systems using the same models. We have an all-sky camera looking up in the sky and in Würzburg, and we have the like normal surveillance camera looking in one direction in Hessdalen, and they both use exactly the same models. So they could be used for other cameras. There would be even an idea which we was discussed is that if others want to, if there are people providing a camera stream for us, we could have a dedicated computer stationed somewhere to evaluate these incoming camera streams and do the detection on these streams. This is also sometimes discussed. One of the many things that we could possibly do if we had more money and more working hours.
So, for instance, if someone give you a lot of pictures of birds, for instance, can you take that information and put into your system so your training for birds will be better?
I mean, probably more training data is always better. But I guess we have enough birds in our database by now. Yeah, but maybe what you are suggesting is to use some open available training data sets with like birds that are already pre-labeled. Like I think Google provides some of these or something like that.
Yep.
Yeah, that could also be an option. Yeah, it would probably make sense. It just needs to be done.
Yep.
Yeah.
I just a comment on that. I think if you read the kind of research papers about this type of tracking system, most people they actually do that. They get the pre-labeled and kind of do the basic training, and then maybe they add some layers in a network or something with a specifics if they want to have a specific. So I'm a little surprised that you didn't do some basic training with available images. To be honest.
Actually, now that I'm thinking of it, it's very likely that we did that. It's just at the time this was done, I wasn't part of the chair, so I wasn't there to witness how it happened. But yeah, I mean, if you start a system without training, you need data sets, and obviously at the start we didn't have any, so it is most likely that the first ever network was trained on such labeled datasets. Yeah, that's probably how it happened.
Yeah, and I mean, if you're using TensorFlow, maybe you use a pre-trained, basically trained image recognition system that has some parts of it. But I'm wondering, wouldn't the big challenge here is to get this 500 down to maybe 5 or something? Because I mean, when you produce, like I do, produce a lot of video, there's so much. When you start having that much false alarms, it gets so tiresome to go through it, right?
Yeah,
And
and also the
so
hard drive popping up there.
yeah, so what's kind of the roadmap for? Is it just more people, labeling this stuff, or is there any else improvement you can think of doing?
Well, we have a lot of improvements that we want to do. We have discussed a lot of options how we can improve the system, but it is simply the same problem. I will say it again and again that this project is very poorly funded. There are really, really low working hours that can be spent on it. And it's just simply a matter of actually doing it. And most of the stuff we can't actually do at the moment because nobody is getting paid to do it. Yeah.
Yeah, I mean, if you read on the internet, you will find similar research projects, but they're focusing on drone detection, and that has a lot of. They get a lot of funding. Why? Because drones can be lethal.
Yeah.
But they're building similar systems using more or less same type of neural networks, same type of methodology, just that they train to identify hostile drones instead of UAPs, right? So it's sad, but that's how it is.
Maybe these. Yeah, go on.
I think it will be possible to find volunteers who are willing to do much of this job without any paying. So as long as the case is interested enough, it will be possible to find someone who is willing to do this without any paying.
Yeah, that's also the reason why we plan to go open source. Yeah, so yeah, we want to make use of that option sometime in the future. But yeah, we still need more people in Würzburg in order to coordinate this shared development. And yeah, so I can say more or less I am more or less the only person working on it. Another person is also slightly working on the system. And I can tell you, besides, I already am pretty occupied with maintaining the system itself and fixing some minor bugs and bringing in some minor features. Yeah, we just would need 1 or 2 full-time persons to coordinate all these other projects, and then we could also start going open source and coordinating software changes with volunteers and giving out the client if we have moved the server into the open internet and coding such stuff. Yeah, but we hope to find somebody for that soon.
Yeah, I would really like to see if we are able to get more people and invite more people. I think it has to do with kind of getting the message out, let people see what is going on. If they see this is interesting and they would like to join, then let's try to make it possible for them to join. Um, and then, but I also think we need to make it kind of explicit, like, yes, we need someone to do the maintenance of the repository for the open source. We need somebody to do the checking of the false alarms and classification. We need somebody to kind of make that kind of specific so that people know that, yeah, I can do that. So I would like to see if we can kind of make a plan for how to approach this. But also, I think it's very interesting to know how much it will take to make the next duplicate and the next system set up. So, because I need the price before we can go out and ask for the money. Yeah, yeah. I am very happy with it. It's very interesting everything you said. I'm so glad about you could take this time. I know you have been very busy too. Um, I think we should round off. It's been a while now. So if there are any other questions, you have to hurry up, people. I have not checked if there's anything in the chat. Let's check out that. Where's the chat? I can't do this.
Just a comment from me while you do that. Thank you, Marvin. We had a good time, and see you soon again in Hästdalen. And we'll do some more work and some other stuff. Hopefully, we will share accommodation, and hopefully we'll get some good ideas flowing in there. And yeah, I think whatever we can do to help improve this system is very valuable to everybody involved here, because we want it to become really smart. So yeah, but I mean that's the idea, to filter out most stuff. And
Yeah.
I mean, in parallel, I'm running this motion detection based system, and it's not producing 500 false alarms per day. But on the other hand, it's not smart either. So it's just about parameters like the path the object is moving and some very basic motion detection, but it's very stupid. Other than that, it doesn't produce a lot of false positives. But some days, like which really windy days, or clouds are moving a lot, low altitude clouds, it can produce a lot of false alarms. I mean, really, hundreds of them, and because it's stupid, right? So that's the difference.
Maybe we just have to say that if there are any more questions, then they can meet you in the field trip and the conference that we're having. Yes.
Definitely.
But I should also warn people that I have set the limit to the number of people that can sign up, and we are already past 33 people that will come to the conference. And I think I know that there's at least 5 more that's going to be signing up. And we are beyond the number that Erling said, no more than, and it's much more than that. So if people want to join, you have better hurry before the limit is reached. But I'm really looking forward to have plenty of time talking to you in September. Yes.
Yeah, it will be very nice to meet in real life for the first time, or
Yes.
again with
Yes.
Magnus. Yeah, I'm looking forward to the field trip event. It sounds
Yeah.
pretty nice, adventurous.
Yeah, and welcome to Trondheim soon. I'm really happy you're coming over here for real. You will have just a 2-hour drive to Hestdalen. We can go there together and figure this out, solve this riddle for once
Yeah.
for all.
So I'm already planning what to do as a tour guide for Massimo. So I'll use the same plan when you come. So I'll have something to show you. Trondheim is a nice place. Thank you very much. I think we should
Yeah, thank
end
you.
it now, and I will send you the recording after.